In this video we'll look at the use of the delta symbol. The Greek letter delta represents a change in a variable. So if we have some variable x, then delta x equals the change in x. If we're thinking about a production function, we'll have y as a function of k and L. If we hold k constant, so delta k, the change in k is equal to 0, and increase labour by 1 unit, so delta L equals 1, then the change in y, delta y, is equal to the marginal product of labour. Well, that's basically the definition of the marginal product of labour. We can think of that more generally. So again, holding k constant, the marginal product of labour is the change in y divided by the change in L. Of course, if we take the limit as delta L approaches 0, then we have our first partial derivative. Next, let's think of consumption. So here we're thinking of y is equal to c plus I plus g. We want to think about the change in c. Well, the change in consumption, c, depends on the change in disposable income. Disposable income is y minus t. So delta y minus t is equal to delta y minus delta t. So when we have a change operator, delta, we can expand the brackets. So the change in consumption is equal to the marginal propensity to consume, MPC, times the change in disposable income. Marginal propensity to consume could be, say, 0.8. We can expand that, just as we expanded up here. We can expand this term. This time we're multiplying by the marginal propensity to consume. The change in consumption then is equal to MPC times delta y minus MPC times delta t. Let's put this notation into practice with this example. We have our national income identity, y equals c plus I plus g. We're given that the marginal propensity to consume is equal to 0.8 and the marginal product of labour is equal to 20. Now we want to calculate the change in national saving for a change in these four variables, A, B, C and D. Well, the first thing we want to do is to get an expression for the change in national saving, starting with our national income identity. Well, at equilibrium, investment is equal to national saving, so we can substitute in here for S and rearrange. So we have our national saving is equal to y minus c minus g. Well, the change in national saving is simply equal to delta y minus delta c minus delta g. We were given the marginal propensity to consume, so let's expand the delta c. C is equal to MPC times the disposable income. We saw how we can work out the change in consumption. So subbing in for delta c here, that's a value. We can see we get the change in national saving is equal to the change in national income minus 0.8 times the change in disposable income minus the change in government expenditure. We can simplify further by expanding this term here and collecting like terms. We have delta y and 0.8 delta y. Well, that makes 0.2 delta y. And then minus 0.8 times minus delta t is equal to plus, remember the change in sign there, plus 0.8 times delta t. So now we have an expression for the change in national saving. We can answer parts A, B and C. Well, the first, A, was the change in government expenditure of plus 100. Well, here there's no change in tax and no change in national income. So the change in national saving is just equal to minus delta G, minus 100. Change in tax of 100, delta Y is equal to 0, delta G is equal to 0. So our change in national saving is 0.8 times 100, 80. And part C, well this time an exogenous change in output of plus 100. Won't have any change in tax and no change in government expenditure. So delta S, change in national saving, is just equal to 0.2 times 100, 20. In part D we have a change in the supply of labour of plus 10. Well, we don't have labour in our delta S formula here. We do know, however, that output is equal to the marginal product of capital times the quantity of capital plus the marginal product of labour times the quantity of labour. That being the case, if we have a change in labour, delta L, but no change in capital, delta K is equal to 0, so that goes. We'll have that delta Y is equal to MPL times delta L. Now we have an amount for the change in Y. Delta T and delta G are 0, and we find that the change in national saving then is 0.2 times delta Y, 40. The use of the delta symbol is very common not only in this course but in economics in general. You should practice until you're familiar with it.